This is Mrs. O'Neill for AP Chemistry, Chapter 3, Section 4, Avogadro's number and the mole. You should have watched that intro lesson on the mole. Here are my notes. You should know Avogadro's number. It is either 6.02 or 6.022. Use the number that's on your reference sheet. This allows us to deal with the massive number of atoms that are found in matter. Then he did a reaction, the ethanol alcohol reaction, and he said those coefficients really represent the moles. So we want to remember that 1 mole of the alcohol plus 3 moles of the oxygen gas in the air produces 2 moles of the carbon dioxide and 3 moles of the water. Gave a nice flow chart as usual. He talked about Avogadro's law, which should make sense. As we increase the volume of a gas, the number of particles are going to increase no matter what the gas is. Well, really that should make sense, right? If you got a bigger balloon, that means you got more particles in there. So again, he talked about how mole is a quantity, right? 6.02 times 10 to the 23rd, just like a dozen is to 12. He talked about how much that mole really represents and how it forms a bridge. And we'll talk about Mole Island. I like to call it Mole Island. Some people like to call it the mole roadmap. Either way, it's to get you to understand that this mole is the bridge from any unit over here to any unit over there. So we're going to talk about how that mole really connects a lot of the units. He did a couple of examples, and this one was of AMU CO2, and he just kind of went through the example on how do you use the mass on the periodic table to get to that gram per mole. And remember, when it says gram per mole, the per really means 1, and we can use it as a conversion. He did another example of nitrogen monoxide. So here's an example of using that bridge when he went from 9.01 grams of water to 3.01 times 10 to the 23rd molecules of water. And again, look how he's writing everything. He's writing a number, a unit, and the substance. And that's going to be really important later. Number, unit, and the substance. Because you want to remember that you need to cancel units up and down from each other, across from each other, until you get to the unit that you desired of the correct substance that you desire. He also did another example of converting grams to molecules of glucose. Again, hopefully that kind of rings a bell because this is still just review of Chem 1. So on to your notes packet. Again, I'm going to suggest pausing the video, filling in the blanks, also pausing the video and trying the practice problems, and then playing the video for the information. So your objective here is going to be using the formulas to relate masses of substances to the number of atoms, molecules, or ions in that substance. So it's a relationship that leads us to this critical concept of the mole, which really is defined of 6.022 times 10 to the 23rd. And it could be anything. If you have 1 mole of apples, that means you have 6.022 times 10 to the 23rd of those apples. So think of that mole as just another unit of measurement. Just like you learned one time that there are 12 inches in 1 foot, there are 6.02 times 10 to the 23rd anything in 1 mole. So again, pause, write in those blanks, and then play to hear my words. So again, particles we refer to atoms, ions, molecules, or formula units. So of course, atoms are elements. Ions is when those elements become ions because they lost or gained electrons, or polyatomic ions. Molecules are usually referred to for those covalent compounds, and formula units are referred to for those ionic compounds. And remember, molar mass in grams could be formula mass, could be molecular weight, all of those same terminology. And 22.4 liters is for gases only. So 1 mole can equal any one of these things. like I mentioned before, Mole Island. I always like to call it Mole Island because I like to pretend that we have 3 islands, okay? Volume Island, Mass Island, and Particle Island. And you cannot go from Particle Island to Volume Island without getting eaten by some of those alligators in there. So you must go from Particle Island to Mole Island back to Volume Island. So again, this mole is really that bridge that relates all of these units together. And I believe some people, some teachers, or some books call it the mole road map. So this is something that, again, hopefully is understandable, and stoichiometry is a tough subject for most students, but we want to remember that the sequence is always the same. No matter where you're starting, number one, you always want to get to moles, okay? So far, this is all you know. Particles, mass, volume. Somehow you have to get that to moles. Once you're at moles, number 2, you're going to use the mole ratio, which comes from the coefficients from the balanced chemical equation or the chemical reaction. So that's going to help us get from one unit to another, or I should say one substance to another. We're still dealing with moles, but it's going to be dealing with one substance to another. So here again, here's moles of A going to moles of B, and then moles of what we want. So what we have to what we want, okay? And then, of course, the third step is really getting from that mole of what we want to any unit that we want, whether it be particles, mass, or volume, okay? So again, the sequence is always the same. This is actually a simple representation because later on you're going to see this side filled with lots more than just particles, mass, and volume. And of course, it's a mirror image on the other side. So this is, I'm kind of stating the same thing, but you got to get to understand you're going from any one of these units to the moles of that substance. You're going to use that mole ratio from the chemical equation to get from substance A to substance B, substance of what you have to substance of what you want, and then back to any of those units. So you can start out with any unit, end with any unit, and you're just going to use the mole coefficients in between. So just like he did, you need a number, a unit, and the substance for all parts of those calculations. This way you can really keep track of what's going on. So again, just another visual to get you to understand how the setup looks like. At least this is what I always do. Start with the given over 1, the moles of the given over whatever conversion you're using. Here the C's are the coefficient from the balanced chemical equation, and then the mole on the bottom to get rid of moles of what you want, and then whatever unit you want on top, so they cancel out. So again, your answer should be the answer number, the unit that goes with it, and the substance it corresponds to. So the mole ratio is the only time you use those coefficients, the only time. Everything else is 1 mole. So I'm going to go back to that again real quick. 1 mole here, 1 mole there. Okay? So when in doubt, go to moles, go to moles, go to moles. Once you're at moles of anything, you can go anywhere. And again, these are simple compared to what we're going to see later on in our AP chemistry course. So let's do some practice problems. Again, here's 3 of them if you want to pause now, or again, do little by little. But pause, see how much you can do, and then play the video to get the answers. So number 1, and again, go to the correct sig figs. Hopefully you saw that 490 is actually 2 sig figs. So we're going to work from going to liters to moles. There's the setup. If you don't have that, now work it out. And I always like to say, do the mathematics in order. 490 divided by 1 times 1 divided by 22.4. This way, I know you know what multiplying and dividing by 1 is. I get that. But this way, you know at the end, you're truly dividing by the 22.4. And for these type of calculations, most of the time, they're going to let you use the calculator. It'll be in your free response part of the AP exam. So just put the ones in so you don't mess up the multiplication and division. Hopefully you got 22 moles because of the 2 sig figs from the 490. But notice, number, unit, substance. Okay, how about this guy? You're going from ions to grams. So you definitely want to go to moles first. And then, since it says grams, in my head, anytime I see grams, I think molar mass. So here's our ions, 2 moles. We're using the 6.02. If you use 6.022, your number might be just slightly different than mine. But there's another step here. So now that we're at the mole unit, now we're going to use formula mass of the chloride ion. And again, put it into your calculator correctly and use that EE button for that times 10. Again, if you need help with that, let me know in class, and you should get that as your answer. 3 sig figs we started, so 3 sig figs we end. Number 3. Now, did you catch that? It says atoms. So they're giving you a diatomic molecule starting with grams. I'm going to use that formula mass to get to moles. But they want you to go to atoms. There's that extra step. So here's probably what you thought of first, right? Grams to moles, moles to molecules. This is a molecule. This is not an atom. So you need that fourth conversion there, or the fourth step, third conversion or fourth step to go from 1 molecule of hydrogen diatomic to 2 atoms, 2 hydrogen atoms that are in there. So that's your answer there. Okay, and again, 3 sig figs. See you in class.